Yo, what's up? This is Hakeem in the house with the science turistas. All right, what are we doing?
Over the door of this room, let there be a sign,
on which the figures of a lamb, a dove, and an olive branch should be painted.
together with the following inscriptions in letters of gold:
Peace on earth,
goodwill to man.
Benjamin Banneker, first African-American astronomer and designer of Washington, D.C. From physics
to botany
to food.
My name's Mirabai.
I'm Jasmina.
I'm Ramil.
And I'm Jarita.
And this is Science Tourist Washington, D.C.
Oh, that was cool.
This is a chef.
Yes, I am.
I was 24 when we opened this place. 24. I was 24. Now I'm 84.
Wow.
It's been a little while.
Yeah. So
And-
did you only have the restaurant, or did you have a day job too?
No, we only had, I went, this was a very prominent, classy, but segregated African-American community when I was young. And I came to Washington at 22. This was a very beautiful community, but it was a segregated one. So we didn't go downtown for dinner or to the movies or anything, but we had what we needed here. Mm-hmm. My first job was at the bank, which is a block and a half down the street, Industrial Bank. That bank is still there.
Oh, look at that.
And it's
And you're one of the few companies
today.
that's still
Being operated today by the third generation of the original African American family.
Wow.
We were, a very self-sufficient community. That's why Dunbar High School, our first public high school in this country, became such a prominent school. That's why Dunbar High School had higher test scores than the white schools back in the 40s and early 50s because of all the PhDs that taught them.
Wow.
There were all these women PhDs who couldn't get jobs, so they all taught high school. So they had fabulous scientists as
And
teachers.
great education, exactly.
Yeah. So the same
exactly.
thing happened here in the black
Right
community.
in the black community, absolutely. And it's so wonderful that you guys are here.
We're excited.
Trying to
Yeah.
spread the word about science.
The
So
science.
this will be her first not made at home chili. Ever.
Yep.
Ever.
But she's vegetarian. It's not real chili. It's not real chili, darling.
That's brilliant. I love it.
Why is it a secret recipe?
The secret recipe has to do with the spices that's used in the chili.
Oh.
Right? Yes. Mm-hmm. And then we add all fresh ingredients and make it I'm going to say just plain old love. But the secret recipe are the spices.
How many spices do you use?
Oh, bunch. A bunch.
So she's going to get behind the counter. You have any tips for her while she's back there making food?
Oh, you're going to go back and make something?
Yep.
All right. Well, just to make sure you don't spill anything.
Okay.
And don't burn yourself.
Oh.
Try
So you'll be just fine.
Thank
You're
you.
a small place, but take good care of you.
So meet the team. This is Jasmina. So Jasmina, let's take your order. Grab a pen. We really never close. Basically, we have 3 different shifts. Really 4, because then it goes into cleaning crew. So it never closes, but breakfast starts as early as like 2:30 to start prepping for 6 a.m. open.
Hello, what would you guys like to order today?
I like vegetarian chili fries. Thank you.
And what are you going to get for your sister?
Nothing from Mirabai.
So what we noticed, mom and pop, for a long time, we only sold the half smokes and hot dogs, the beef dogs, and then we noticed as the area changed, there were more requests for vegetarian and turkey, those who don't eat beef or pork. So we created a veggie chili, and basically it's pretty much the same recipe. We just pulled the beef and we put texturized vegetable protein in it. So let's start. We make the drinks first. So each get 3 napkins.
Okay, gotta be careful.
Yeah, mustard, onions, chili, and cheese. Perfect. And this is the famous chili sauce right here.
Ooh, wow.
The secret is you're going to take a little bit and pour it in one straight line. Because it's all about presentation, right? Of course.
Serving. Your order is served.
Excellent. Awesome. Those look great.
How good is it? I've never made chili.
You did. Oh, you did good.
I'm here in the northwest suburb of Washington, D.C. at the Department of Terrestrial Magnetism. This is the site from one of the greatest and most profound discoveries of the 20th century, the discovery of dark matter. It was done right here in this building by a woman named Vera Rubin, one of the great astronomers of the 20th century.
We're at the Department of Terrestrial Magnetism of the Carnegie Institution, and this was Vera's scientific home for nearly 40 years. So I'm a staff scientist, which is a job description that no one ever knows what it means when they see it written down. Really what it means is that I have 100% of my time to do curiosity-driven research, and my particular field is to study planet formation. I'm an observer. I study certain stellar disks, the formation of planets within those disks, look for young planets, look for some old planets, try to understand how unique we as a solar system and as a planet are in the universe. It was amazing to share this space with Vera for many years. I was privileged to have the office next to her from 2001 to the time that she really moved away to Princeton a few years ago. And she was really the founder of astronomy here. She was the first observational astronomer to be on the staff here, and she shepherded the group through many changes. One of the lovely things about Vera is that she was a very modest person. She embraced all kinds of science, and she really welcomed everyone here who studied anything interesting. It didn't matter if it was what she did. But she was certainly the first woman in this department, and it was always an ambition of hers to have more. She was not satisfied with our gender ratio, and that came up every time we hired a staff scientist, where she thought we should use any opportunity we could to hire more women. So every year when it came time to make nominations for prize fellowships or prize at the American Astronomical Society, you knew she would be busy in her office writing nominations for women. She also took the time to support younger women. She was an avid judge of the Intel Science Fair, and one of the things I think she enjoyed was talking to the really outstanding young women who came to that science fair at the high school age. Vera would write letters whenever she saw an injustice done in an article, and so there had been a Physics Today article, I think, with a headline of something like, "Men of the South Study the Universe," and it was a lot about her work, and she had been at the observatory, and so she had written a very humorous and yet pointed letter to Physics Today about this article, and so I found that and many other clippings that she had made over the years.
Okay.
So a little delve into history to clean out her office.
So she was quite the activist.
She really was. And I gather she had really been an activist about the Vietnam War in her younger days, but when I knew her, it was mainly activism on behalf of women in science.
Today we have an artifact from our collection that was used extensively by Vera Rubin during her career here. This is a measuring engine. So in the era before scanners and digitization, astronomers needed a way to map the positions of the spectral lines on the spectra they recorded at telescopes, and this machine allowed X and Y positions to be determined very accurately. So you looked in the microscope here and lined up a crosshair with the position of the line. You used the wheels here to position it just exactly, and then this machine was connected to a card punch, which is a way of old school. So you'd step on a foot pedal then, and that card punch machine would record on an IBM card the position, and then that could be read by an old-fashioned mainframe computer. So her work for many years, and with her colleague Kent Ford and others at DTM, was to understand the rotational properties of spiral galaxies. Why are they spinning the way that they do? And ultimately, the insights gained from those studies led to the recognition that there must be unseen mass in the universe, in galaxies, that are causing galaxies to accelerate the way they are. Dark matter, exactly. This is Vera's personal photo collection that documents basically her entire career in science. The observatories she worked at, the conferences she attended, some great shots here. So this is very early in her career at DTM. This is Vera with Kent Ford in the hard hat, and this is at Lowell Observatory, and they're installing one of these image tubes on a spectrograph, on a Carnegie spectrograph. Oh, there's a nice photo here of Vera with several postdocs around 1970, I believe, and here she is actually using the measuring engine that we talked about earlier to digitize spectral lines. This collection really is a wonderful visual record of the astronomical community, not just Vera's work here, but also her engagement in all the lectures that she gave, the awards she received, the places she observed, and the friendships and colleagues she did.
Well, thank you very much, Sean. This has been
pleasure.
Absolutely fascinating.
Pleasure.
Ooh, this is my favorite building.
Whoa, what the heck is that? Oh, it's the Smithsonian.
Look at the Washington Memorial.
Here we are at the National Botanical Gardens of Washington, D.C.
Look, there's Thomas Jefferson.
Today we have Devin, who's going to tell us a lot about the Botanical Gardens.
Welcome, glad you guys are here. We've been here for almost 200 years. We were founded in 1820 by Congress after letters from 3 founding fathers, George Washington, Thomas Jefferson, James Madison. They all wrote letters saying when they were working on the District of Columbia, they wanted a national botanic garden for people to connect with plants. And so we got that charter in 1820, and we've been around for almost 200 years now. And every day we bring through people, about 1.3 million total every year. We're typically the #1 or #2 most visited public garden in the entire U.S. So a lot of people coming in checking out plants. And we got some pretty cool ones here if you want to talk about one right behind us.
Yeah! So what is this plant?
Well, you might not know it by looking at it, but this is where we get chocolate. This is Theobroma cacao. This is the chocolate tree, as people like to call it. And these really beautiful golden-shaped pods are the fruit that is ripe. So it has a really cool trait called cauliflory, where the flowers grow directly on the trunk all the way down. And that's why you can see we have the flowers growing right here, or the fruit growing right here. And it takes about 6 to 8 months from the total process of getting the flowers through pollination until getting ripe fruit. And then really all you have to do is cut those open, and you'll have about 25 to 30 like kind of big sized seeds in it that you would dry and roast, and you got cocoa nibs. And if you want to put it under pressure, that's when you separate it and you get cocoa butter for lotions and white chocolate, or the leftovers is like cocoa powder for hot chocolate and making cocoa chocolate bars. But this is it. This is where it all happens. Pretty pure process coming directly from the tree. You just don't see the tree.
So why don't we see the tree?
Well, it doesn't really grow in this area. It's a little too far north. It gets a little too cold. Native more toward the Central America area. Today it's grown also in a lot of the African countries which have a similar heat. And so you're not going to see it this far north because it's getting too cold in the winters.
So it's a tropical plant.
It's going to be a tropical plant, yeah. And we got several plants in this room that are tropical that we eat. You might see bananas or coffee.
Cool. So should we?
Yeah, we can go explore something else. Here's some. Yeah.
Coffee.
We're in this room filled with lots of things that we use or eat, and in particular coffee also grabs people's attention. Most people have it almost every day, and it comes through us from a long history of people using this plant because the caffeine in it can actually help with heart issues. And so as long as you're not having it in crazy high amounts, you don't want to be drinking 20 cups a day, but if you're having a small amount, it actually can really help with heart issues. And so it comes to us with a long tradition of medicinal use, and it grows as an understory plant, which means it typically would be found under other trees. So it's not going to want a lot of really bright full sun, and that's why you see ours planted under some trees like this. But we got some fruit happening, and people love to see where their morning cup of joe comes from.
Oh, interesting. I don't drink coffee, so.
One day.
I don't think so.
You don't think so? We've got tea. We totally got the other plants for the other side of the world. That if you don't want coffee, we've got tea too.
Perfect. Heck
Here,
yeah.
you can hold the pumpkin.
In Arizona, you wouldn't have rotting pumpkins because the javelinas would come and eat them all.
Yeah, in the wild, pumpkins are eaten by a lot of animals, and so humans eat them today. We eat the insides, we eat the seeds, we do a lot of stuff with the pumpkins. Clearly, we like to carve them, and we like to make decorations and stuff out of them. But pumpkins, squash, and gourd are all part of the same family, the Cucurbita family. So this one's definitely one native to North America that people have been using for a long time, and we still use today. And they're beautiful. There's so many. There's more than 700 different kinds of the Cucurbita family of these pumpkin squashes and gourds.
So are all of the squash Cucurbita family edible?
To my knowledge, every single one of them.
Sweet. So like the small decorative pumpkins that you get at the store, can you eat those?
You could, but you've also asked me an interesting question that we get a lot here at the Botanic Garden is, quote, can I eat this plant? Well, technically you can eat any plant. The question is, would you really want to? Is it sweet enough? Is it too fibrousy? Is it kind of going to hurt your gums? Is it going to cut you up on the inside? Right? There's lots of questions that go along with eating plants. The question is really, would you want to? Is it palatable? Is it pleasant to eat? Right? And from my understanding, Cucurbita family, you're going to be happy with most of them, but some of them are not going to have much fruit. So if you're talking about really tiny ones, it might be a lot of rind, essentially.
I like pumpkins.
I like pumpkins too. Pumpkins are fun.
So, what's this?
It's vanilla, which is super popular. You probably have it almost every day in something, but most people have no idea that it's actually an orchid and that it grows on a vine like this. This one that we have growing behind us on the wall, it's about 2 years old, about 2.5 years old. It just gave us a first really good batch of flowers this summer, and we did some hand pollination. And in fact, most all of the vanilla that we eat today, instead of growing in Central America where it's native to, it's almost all grown in Asia, and it's pollinated by hand. They go through the fields and they pollinate it all by hand because they don't have enough of the insects that would pollinate it growing there. And so talk about a very intensive process to get from the flower to the fruit. Vanilla is one of those. One of the other things that I wanted to point out to you is that up high, we might have some vanilla pods that are starting. So after we did the hand pollination on those beautiful vanilla flowers, the seeds start growing in that very distinctive long pod. So you had a question about a plant. Which plant?
That one.
This plant. What do you think this plant is?
An alien.
An alien. Yeah, it's banana. It is banana. There's a lot of different types of banana, but we really only today eat one specific type in the grocery store. If you go and you buy a, quote, banana, it's a Cavendish. They're all clones of the exact same type of plant because it is the best one for both growing the right size, giving us the right amount of sugars that humans like to eat, the right sweetness level, and it's very transportable. This is not Cavendish. This is a different variety called Praying Hands. So this is not the one you're going to find in the grocery store. There are many types of bananas though, and a lot of them that humans don't eat because they're not the exact level of sweetness that we would like. Other animals might eat them, right? They have a different level for what they want to eat. But this is not one that we would eat. But the great thing about this one, because we have both flower and fruit on this one, I can show you a little bit more about how it grows. It's actually a grass, and it doesn't form wood. The whole thing is just big leaves wrapped around each other, and they get really strong and tall to stand up straight. And then after they produce one round of fruit, that specific, what we call a tree, is going to fall over. They're monocarpic. That means they only do one time, and then they start over, and that one will fall down, and another sucker, you can see a small tree there beside it, that one's going to come up next, and it'll produce fruit next. And so, I know, right? The whole process, depending on the type of plant, might take 9 to 10 months. So that same offshoot coming down there, that bract, is going to make both male and female flowers in succession. And every day they're pollinated by bats. This plant has so many cool things. The bats are going to go and fly and be attracted to that fresh flower that's opening up. And if you get close to some of them, if it's ever hanging down really low, you'll see it's like sticky sweet with the sugars coming out of the bract there. The bats are very happy.
So we're talking today about dark matter.
You always talk about that.
I always talk about that, don't I? So what were we doing at DTM? Do you know?
What's DTM?
There's a very famous woman astronomer who worked there named Vera Rubin.
Oh, I know her.
You've heard of her?
Vera Rubin was interested in galaxies, like our own Milky Way. You've probably seen a picture of our Milky Way. It's a big spiral galaxy, right? It has all those spiral arms. In fact, our galaxy is rotating. Most astronomical things are orbiting around something else. That's how it works. That's how gravity works. For instance, our solar system. If you look at the planets in our solar system, Mercury, Venus, Earth, the thing you notice is if you measure the speed at which things are going around. Closer things, like Mercury, are whizzing around the sun super fast.
Okay, let's make Jazzy the sun. She's sunshine. If Jazzy's the big old sun, and I'm just very close to the sun, pulling it in very fast, then Mercury has to spin around really fast so that its centrifugal force balances the big sun's force, right? Whereas if you're further out, you can kind of go slower. You don't have to go so fast, right? So Jupiter goes around in 12 years.
This graph of speed against distance is known as a rotation curve. So what Vera Rubin did is she decided she was going to measure the rotation curves of galaxies. In other words, she was going to discover how did galaxies spin as you go further and further out from their center. She, like everyone else, was expecting that as you go further and further out, the stuff was going to move around slower and slower.
Right, that's what everyone would expect.
But that's not true.
But that's not what she found. What she found was that things going close were moving at this speed. Things going out here were also moving at that speed.
Heck.
Oh, heck.
So, to Vera Rubin, either the laws of gravity somehow no longer worked when you talked about the scales of galaxies, or there was a second alternative, that as you got further and further out away from galaxies, there was more and more mass out there that we just couldn't see. She called this stuff dark matter.
What? Dark matter.
Da 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 da. Dark matter. So she basically discovered that there's these huge amount of dark matter, stuff we cannot see. We take an image of it, we see this little galaxy in the middle, but then when you start to look at the rotation speed, as you go way far out, way past the galaxy, it's still going on around incredibly fast. And therefore, there must be all this mass out there. So that's kind of the story of dark matter. It's the stuff that fills the universe. There's almost 5 times as much mass in dark matter in the universe than everything in the periodic table. Everything that we see around us, we're just nothing but
We're special.
We're special.
We're
yes.
special. Excellent.
We're at the Potomac River. It's in Washington, D.C. It's very cold. It's very cold. The Potomac is the source of D.C.'s water. There's a waterfall called the Great Falls and another waterfall called Little Falls, which feeds into the aqueduct that feeds into the D.C. water plant.
I don't know if we can zoom in, but right across there you see some domes right across
Yeah.
the river. And that is the Naval Research Laboratory. And right next to it is where they process the water. So the aqueduct carries the water down to the processing plant.
Virginia water is so much better than DC water that Jasmina goes into DC and she says, "Oh my God, the water here I can't drink."
But we're gonna test it anyway, right?
Yeah, to see why it's so terrible. I'm at the intersection between the Potomac and the Anacostia rivers, and I am here to collect water. So we're standing in front of the aqueduct the aqueduct plant. Basically, they take the water from the reservoir and they pump it into here, and then they ship it off to the water treatment plants in DC where it gets treated, and then it gets sent to your taps, people of Washington, DC.
Today I'm going to be testing the water that we got of the Potomac in this cup. First test we're going to do, it's called the 6 tests, which tells us the total hardness, total chlorine, the alkalinity, the pH, and the nitrate content of the water that we'll be testing. Following the instructions, fill the plastic tube to the edged line with sample water. 2. Oh, I can't open things. First test, the 6 tests. So this is kind of a cool strip. So let's find out what they do. Dip strip for 2 seconds. 1/1000, 2/1000. Alright, shake excess water off. And immediately read total hardness, total chlorine, and alkalinity. Total hardness is 100. Chlorine is 0. Alkalinity is 0. pH 7. Then I wait 30 seconds and read nitrate. Okay. 30,000. All right, let's read nitrate. We got 0 and 5. Yay! I'm worried about the hardness. I need to figure out what I just figured out. Let's Google it. The total hardness is the total calcium and magnesium dissolved in the water. We got high hardness water. All right, so the next test I'm gonna do is gonna be the copper test. Same procedure as last time. Immerse copper strips, swirl 10 times, remove with pads face up, do not shake off excess water. All right, y'all ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or wait 15 seconds and compare to the color chart. 15. Whoa. It looks closer to 1 than to anything else, which is disturbing. It's still within okay range, I should say. Next, we're doing the iron test. 1 1,000, 2 1,000. Shake once to remove excess water. 60 seconds and compare to color chart. It barely changed color, which is good because you're supposed to have 0 iron parts per million. This test is the lead and pesticide. Using the dropper, place exactly 2 droppers full of water sample into small test file. Gently swirl for several seconds and place on a flat surface. Place both test strips into the test file with arrows pointing down. Wait 10 minutes. Do not disturb strips or vial during this time. Blue lines will appear on the strips. We've waited 10 minutes, and now we should have our tests for pesticide and lead. It appears that the test tested positive for pesticide and negative for lead.
So this is the actual water. The reservoir that, feeds DC. The water was normal except for it's got a high hardness, it's got pesticides, and it has low alkalinity. It's normal pH. I like water. I think it's really interesting and fun to think about what your drinking water is. Because everyone drinks water from the tap. You should probably know whether you should be filtering that or not,
Hello, we're back, and I'm Jasmina Dave, here with...
And I'm Molly Nuss, and we're here at Moms Organic Market in Alexandria, Virginia. We're just really big about helping the customers and just giving them an experience. Everything in our produce is going to be organic, and it's just top-notch quality. If it doesn't meet our standards, it actually goes into a compost bin, and we basically donate it to Mothers in Need or homeless shelters or other donation-based companies. Yeah. So it's just a really awesome place to work. They're super nice to us, and yeah, we love it here.
So today I'm trying to recreate Ben's chili from Ben's Chili Bowl. Okay. It's the vegetarian one. I'm vegetarian. I have a list of ingredients, which I think that the recipe includes because they didn't give us the recipe. How many spices do you use?
Oh, bunch. A bunch.
So let's see, what's on your ingredient list?
Large can of crushed tomatoes, red beans, dried chili, bell pepper, corn, onion, chili powder, tomato paste, and cumin. And we're gonna pick out some extra ingredients of zucchini, because that's what I wanted to do. Let's go to checkout all the way around.
Yeah.
Made vegetarian chili before?
I have never made.
Never? Okay.
Yeah.
So I was going to say, do you have any secret ingredients we should add?
Well, my little secret ingredient whenever I'm making something is that I like to, weirdly enough, even if it's something savory or sweet, I'll add a little bit of lemon rind or orange rind. and it just gives it a little kick, you know?
We
And
have a
so-
lemon addict over here. She's already taking notes.
I was the same way. When I was a kid, I would just eat whole lemons. I was
That's what she
obsessed. I really was.
Thank you so much. It's been so fun.
Bye, guys.
Hey everybody, welcome to my kitchen. Today we're making a replica of Ben's Chili Bowl chili, but they didn't give us any instructions, so I'm doing it how I want to do it and how I think it should be done. Crushed tomatoes, kidney beans, cumin, chili powder, onions, tomato paste, garlic and green bell peppers, orange and red bell peppers, New Mexican chilies, corn, jalapeno pepper, my good old bay seasoning, sage leaves, some salt, and my favorite, zucchini. So it's all about flavors. Oh my god, it looks great! I think we are ready to add our chili. Ooh, will this make me cry? I don't like onions. Just kidding. Oh yeah. Ooh, that's good one. I forgot to add my zucchini. Dash. Oof. Chicken. Add your cumin. Maybe. Everybody's gonna kill me. Chopping up her plants. Here we go. Hot. Ooh, I've done a good job. Now we sit back and wait. I want to take a nap.
Wow, what's this, Jazz?
That's my homemade chili.
Inspired by
Ben's Chili Bowl. I picked Ben's Chili Bowl because it's the oldest Black-owned food business in the whole of Washington, D.C. So here we have nachos with my homemade chili, kind of sprinkled some cheese on top, around the sides mostly, and then
Any spices?
of course, but those are a secret.
All
Gotta watch
Wait.
that.
All right, can we eat it?
I'm decorating it.
Oh, okay.
All right, here we go. Can we eat?
No. Okay.
All right.
Yes, let's try it.
Psychological chili.
All right, here we go.
Oh my goodness. It's really good.
Yeah, you should try the chili part next.
And tell them what your scientific results were.
Oh.
Right, yeah, so I did test the water of DC.
Hold it towards you.
I did test the drinking water in DC, right, and I found that it's high in hardness and it's low in alkalinity, which is interesting and probably not great to drink. And also it has pesticides. So,
Oh my goodness. Well, I happen to find a home that has a water filter and a water softener. So I have soft filtered water, but you know what? I put the wrong type of salt in it once, and the water started tasting like chlorine, right? And so I thought, oh, something's wrong with the water thing. And I brought a guy in, and he said, yeah, you put in the wrong pellets. So I know it tasted bad when it was unconditioned. So I deal with conditioned water here. But your generation has to fix everything that our generation and previous generations have broken. So think about it like this, right? Homo sapiens sapiens. Farming has been around for, say, 10,000 years. Before there was a single farm, Homo sapiens sapiens went around the planet and destroyed all the megafauna, all the large animals, right? The saber-toothed tigers, the mammoths, they killed them all off. Then with agriculture, we started wiping out the things we didn't eat or use in any way, right? And the animals in the oceans were able to survive, but then in the last century or so, now they're getting wiped out. So, and with global warming, the glaciers are melting, our storage of fresh water, so you better do something. Y'all better fix these problems that your ancestors caused, okay? I didn't come to this planet to get poisoned by the drinking water.
Oh, true.
Humans. Thank you. Thank you. And this is Science Tourist.